So most of the time that we have vectors, they don't end up in a 180-degree angle. So we don't exactly pull exactly apart. We don't pull exactly apart like a tug of war. What usually happens is vectors come at different angles and different magnitudes. So here I have a dock. I have two people on the dock, and this person is pulling with 120 pounds. And this person is pulling with 80 pounds. And they're pulling with a 75-degree angle in between them. And the question is, which way is the boat going to go? And with how much force is it going to go there? Well, we know that this person's pulling with more than this. So we're going to figure this out. We're going to take these three numbers. I'm going to work from 120, 75 to 80, and we're going to figure this out. And there's some notes that are going to go along with this. So the very first thing I'm going to do, according to our notes and according to the procedure that works really well, is I'm going to start by drawing a horizontal line. The next thing I'm going to do is I'm going to pick a scale. That scale is going to be millimeters. I'm going to make each millimeter worth 1 pound. And what I'm going to do is I'm going to place my ruler on my line. I'm going to start here, and I'm going to go out to 120 millimeters and put an arrow. And that arrow is going to represent the tail and the head of my first vector. And that's the 120 pounds. That's this person right here pulling with 120 pounds. The next thing I'm going to do is I'm going to get out my garden tractor, my farm tractor, my protractor. And this is where the measuring from the arrow makes a difference. So I'm going to place my fisheye right on the head of my first vector. I know that the angle, according to my problem, is 75 degrees. It's right here. So I'm going to go 75 degrees, starting at 0 that the arrow is pointing at. So the arrow is pointing at this 0. I'm going to go up to 75, put a dot, and I'm going to draw a line at that angle. This is going to represent the second vector. And that second vector happens to be 80 pounds. So I'm going to come up here, and I'm going to put a mark at 8, which would represent 80 millimeters, or in this case, 80 pounds. And I'm also going to put an arrow on that vector. So now I have my biggest vector here, 120 pounds. I've measured my angle here, so the angle I measured is right here. I measured that at 75 degrees, and then I measured out here 80 pounds to get my second vector. What this does is it gives me a resultant vector if I make a triangle. So now I'm going to make a triangle from here to here. And that triangle represents what's called the resultant vector, and that's this line right here. If I put an arrow on that vector, suddenly I have a true vector, but I have no idea its magnitude. Remember, magnitude is measurement. And I have no idea the angle it is from the biggest vector. So according to our notes, and what we need to do is we need to measure this line. So I take my ruler again, I measure the line, and I find that it is 16 centimeters or 160 millimeters. So I'm going to say this is 160 pounds. I'll write that a little bigger so you can see it. 160 pounds. And I'm going to write at. Because remember, a vector has to have a magnitude, a measurement, and a direction. I need to establish that direction. So I'm going to go from the bigger of the two forces, because then we know that boat's going to go further towards the person pulling with 120 pounds. I'm going to set my protractor here, and again, here's my arrow. My arrow's pointing at this 0, so I start measuring from that 0, and I find out it's about 28 degrees. So I'm going to say 160 pounds at 28 degrees from... And it's always the bigger vector, because we always put our bigger vector down here on a horizontal line. So I say from the 120-pound force. And that is how we do vector resolution of things like this, that we have two people pulling in opposite directions. So to quickly review, I drew a horizontal line. I measured out my larger vector first, which was 120 pounds. I made every millimeter a pound. I measured the angle, starting with the protractor, starting at the 0, where the arrow's pointing. I made that 75 degrees in this case, because that's what the problem was. I then measured up that line. The magnitude of the smaller vector, in this case, was 80 pounds. I put an arrow on that line to represent that vector. I made a triangle. This is the resultant vector. We're going to find out that boat's going to travel at 160-pound force at 28 degrees from 120 pounds, which means 28 degrees from this vector, that boat's going to travel that way with a force of 160 pounds. I'm looking for a force, an angle, and what we measured the angle from. And that's how we get good answers with resultant vectors. I hope that helps. Watch the PowerPoint presentation. It'll give you some really good notes on how to go about doing this.